To see why classification is so powerful and so ubiquitous, and also to understand what exactly is classification, let us go back to our overall cognitive architecture for an intelligent agent. This is a diagram that we have come across many, many times. Let us imagine this particular cognitive system is dealing with a set of percepts. These percepts are in the world. So as an example, this cognitive system may see some object, some animal when the cognitive system goes to the zoo. This might be an AI agent or perhaps your friend who goes to the zoo and looks at some animals, and there are a large number of percepts in that environment, has wings, has feathers, talons, beak, and so on. And for the simplicity, let's assume that each of these percepts is binary. It's either true or false. So either the animal has wings or doesn't have wings. Now, depending upon the percepts and the combinations of these percepts, one might take different kind of actions. So if it's a friendly animal, one might go and pet it. If it's a unfriendly or dangerous animal, one might run away from it. So all kind of actions are possible. Imagine that there are some M actions that are possible. So, and we can again imagine that there is a binary choice here. So the total number of combinations of actions is 2 to the power m. So as an example, if I see a dangerous animal in a zoo, then I might both scream and run away. If I see a friendly animal, I may approach the animal and make cooing noise to the animal. So a number of actions and combinations of actions are possible. And if n is the number of percepts, then I have 2 to the power n combinations of percepts possible. So here is the challenge that the cognitive agent faces. The challenge is that the number of percepts and the number of actions, more precisely the number of combinations of percepts and the number of combinations of actions is very, very large. And we have to map these percepts, combinations of percepts into these combinations of actions. This is a very complex mapping. So imagine there are only 10 percepts in the immediate environment. So I'm looking at an animal and there are, let's say, 10 percepts that I'm paying attention to. Then 2 to the power 10, the number of combinations of percepts is 1024. I'm doing it 2 to the power 10 here because I'm assuming that each percept has a binary value. If I had 100 percepts, I was not looking at one animal, but I was looking at a scene of animals, then I may have 100 percepts, in which case I have a much larger number of combinations. And if I had something like 300 percepts, which is still not a very large number, the number of combinations is, well, it's a very large number, more than the combinations of atoms in the universe. Now, you and I, and AI agents more generally, are constantly faced with complex environment in which there are a large number of percepts and a large number of actions that are possible. So let's go back to something earlier that we had considered in the class. We defined earlier that one way of talking about intelligent agents is to think in terms of how can an intelligent agent map percepts into actions. Intelligence is in large part, perhaps according to this definition, about action selection. The other aspect of this is that if the number of percepts is large and the number of actions is large, then the mapping between them becomes very large and very complicated quickly. But intelligent agents have only finite resources. How is it then that we can select the right action, or at least most of the time select the right action, even when the environment is very complex, and do so in near real time?